Hello Algebra 1 students, welcome to your video on solving multi-step equations. This is mostly review for you. I'm actually going to use the outdoor noise, the crickets and the cars passing by as my background noise for this one. I'm actually sitting on my front step and it's beautiful outside. It's finally nice and cool. Hoodie weather is here. So we're going to use the properties of equality, those good old properties of equality, to solve all the equations. We're sticking with just multi-step equations with variables only on one side of the equation for this video. Let's begin. Alright, your goal when you're solving any equation is to isolate the variable. You're trying to get the variable by itself. You're going to do this with the properties of equality. And with those properties of equality, you're going to undo what was done to the variable. Let's think about our little friend x here. X had a journey. X went on a journey, and that journey started where x was multiplied by 5. Okay, and some number happened there. That's something times 5 gave us that number. And then x's journey continued where 2 was subtracted from him. And the result in the end was an 18. So now we're going to work backwards to figure out what happened to x. So if I was to work backwards in this particular situation, I would start by adding 2. So 18 plus 2 would give me 20. And then I would, the opposite of multiply by 5, I would divide by 5. And dividing by 5 would give us 4. So in this circumstance, x equals 4. So we're undoing what was done to the variable. Okay, think about that. How do we do that? Well, to solve a multi-step equation, we're going to use the order of operations in reverse. Think PEMDAS. Think PEMDAS. So parentheses, exponents, multiplication and division from left to right as they come, addition and subtraction from left to right as they come. Now you're not going to think about the entirety of order of operations in reverse. You're thinking about these two parts. So you're going to undo additions and subtractions as they come, and then we're going to undo our multiplications and divisions. So let's take a look at this first problem. We have negative 8x minus 17 equals 47. So x's journey started off with being multiplied by negative 8, and that result was subtracted by 17, and the result of that is 47. And we're going to start off by undoing our subtraction. So I'm going to add 17 to each side, giving me negative 8x equals 64. All right, then we're going to isolate that x. So we're going to divide off this multiplied negative 8, leaving me a negative 8. Now that's all well and good, but before we quit with the problem, it would be a good idea, it would be valuable to us to go through and check our solution. So just like when we evaluated expressions for replacement values of the variables, we're going to go ahead and set this up, and we're going to drop that negative 8 into place right there, giving me 64 minus 17. That's going to equal 47, and that is correct. It sure does equal 47, so we know we did that correctly. How about this other one? Again, we have two operations. We have division, we have subtraction. And we're going to work again, reversing first the subtraction by adding 12 to each side. That's going to give me 17 here. R divided by negative 2, or R over negative 2, is equal to 17. Now I'm going to reverse this division. We're going to show multiplication not with a dot, but with parentheses. This is going to come in handy. So it's another one of those habits to get into. Show that multiplication with parentheses. That means r equals negative 34. And if we check it, we go in and we put the negative 34 in for r, divided by negative 2, minus 12. Does that equal 5? And indeed it does. We get 17 minus 12, and that does indeed equal 5. So we know we did that correctly as well. So when you solve a multi-step equation, use order of operations in reverse. But there are a couple of exceptions to that rule because that's what always happens in math. Let's take a look at them. One exception that we're going to look at is places where we should eliminate fractions by multiplying first. We want to make things convenient for ourselves. And if we look at this problem, we have 2y minus 9. That quantity divided by 4 equals 11. So in this circumstance, you have y was multiplied by 2, and then 9 was subtracted, and then that result was divided by 4 to get the 11. And that's part of thinking about it from that perspective, that's why we can't just add 9 here to get rid of this minus 9, because that minus 9 was involved in math where then the result was divided by 4. That's not really a minus 9, it's a minus 9/4. So we can't start by getting rid of that minus 9. We're going to start by multiplying. And we show it with parentheses, and we're going to do it by multiplying both sides by a 4. And those 4's are going to cancel on the left, leaving me 2y minus 9 equals 44. And now it's back to being a multi-step equation. What's the next thing I should do? That's right, we should add 9. I can't really hear you, but I like to pretend sometimes. 2y equals 53. Now that doesn't go evenly, but that's okay. Show your division so that you can see your improper fraction. You showed the division so you can see the improper fraction. And 53 halves is a perfectly acceptable answer. If I was dealing with a consumer application, I would want to go ahead and actually make it 26.5, depending on what we were talking about. But 53 halves is the exact answer I want to see, or the answer that I'd like to see when you do something like this in class. We'll go back and check that real quick. So let me switch colors. Let's use that one. And we'll go plug in our 53 halves. Does that give me 11? Well, 53 halves times 2, the 2's cancel. 53 minus 9 over 4 is 44 over 4 is indeed 11. So I know I did that right. Now this one is another one where we want to get rid of these fractions. In this circumstance, I just want to make life easier for myself, and I don't want this fraction coefficient. I don't want to have to add eighths and halves here when I add 7/8 to both sides. So rather than that, we're going to look for our least common denominator, and we're going to multiply the entire equation by that least common denominator. Well, we have halves, fourths, and eighths. 8 is the biggest, and both 4 and 2 go into 8. So that's convenient. 8 is our least common denominator. So we're going to multiply the entire thing by 8. I never realized how many people drive past my house at this time of night. It's actually really a lot. Anyway, we're going to multiply by 8. So 8 times 3/4 of c minus 8 times 7/8. And that equals negative 1/2. Again, times 8. All right, 8 times 3/4. 8 times 3/4 is 3/4 of 8. 3/4 of 8. So let's use my space up here. 3/4 of 8. Well, 1/4 of 8 would be 2. So 3 of those would be 2, 4, 6. 3/4 of 8 is 6. So 6c. 8 times 7/8, so the 8's will cancel there, so minus 7. And then negative 1/2 times 8. Well, I know it's negative because it's a negative times a positive. Half of 8 is 4, so negative 4. I'm going to add 7 to each side. 6c equals 3. Very common mistake here is to see a 6 and a 3, to know that you've got to do some division, and to say, oh, it's 2, it's 2. Well, is 6 times 2 equal to 3? No, it's not. So write it out. Finish it by writing it out. So divide by 6. And c equals 1/2. C equals 1/2. So now I can double check that by plugging in my value. But I am kind of out of space here, so it's going to be very small. So 3/4 times 1/2 minus 7/8. So that's 3/8 when you multiply it out, minus 7/8, which is negative 4/8, which is indeed equal to negative 1/2. So we know we did that correctly. Check. All right. And again, same idea over here. We checked it, so we know we did this one correctly. All right. One more weird exception to the rule. So in this case, we have a problem where we have to divide or use the distributive property to remove parentheses. And I wanted to point out that this can be done in 2 ways as well. So let's start with one where I'm going to distribute that negative 3. So I'm going to actually start off by rewriting the entire thing using the symmetric property, because I like to have my variable on the on the left-hand side, not the right-hand side. And we're going to distribute that negative 3. A cricket just jumped on me. You'd think I'd be totally used to stuff like that, but I'm not. Negative 3 times negative 11 plus 33. Or if we thought about the way we talked about in class, minus a negative 33. All right, now it's a 2-step equation, so I'm going to do my addition or subtraction first by subtracting 33, giving me negative 51 equals negative 3x. And then I'm going to get rid of my multiplication by dividing. X equals, all right, negative divided by negative, so I know my answer is positive. 3 into 51. This is a great opportunity for me to review something called short division. I don't like long division, I like short division. So 3 goes into 51. 3 goes into 5 once. with 2 left over. 3 goes into 21 7 times. And so we end up with 17. All right? But notice here that this is 18. Negative 18 equals negative 3 times this quantity. I could actually divide off this negative 3 from the beginning. And that is a cool trick to look for, because watch what happens once I do that. It's just a one-step equation now. Add 11 to each side, and you get your 17 again. Let's check it real quick. Let's see. Color, color, color. All right, so negative 18 equals negative 3 times 17 minus 11. All right, so 17 minus 11 is 6. Negative 3 times 6 equals negative 18. It sure does, so I know I did that correctly. All right, so either way, we got our 17. So I think the point of showing you this last example was to show that you have options, you have choices, and we want to be able to adapt. We want to be able to see tricks like this to make it faster to do the problems. Thank you for watching and for taking your notes. So far I hope you noticed that I do love my memes, and I do like to create some of them online. It aggravates me no end that this one is like cut off on the end, so I'll fix it real quick. There we go. Much better. Alright guys, I'll see you in class.